We're going to do a code walkthrough for Joshua's algorithm. All right. We know that the node we choose is A, so we're going to try to find all the short paths from A in the graph, okay? And our graph is represented in an adjacency list, and we call it in this parameter, and we call A in this parameter over here. All right. A, and then our adjacency list gets called here. All right. This gets initialized here. We have 6 nodes, and all our 6 nodes get initialized to infinite. All right. And then the distances. So since A's, we're trying to find all the short paths from A. A is 0. Okay. Distances. And now we put A in the heap. Okay. We're going to keep looping until the heap is empty. And it's a min heap, just to be clear, a min heap. All right. So the vertex or the node is A, it's a 0. All right. And then let's go check. So right here, current vertex is A, which then is 0. And then the current distance is 0. So we do not continue. All right. And then we go over here, neighbor weights, we go through A horizontally. All right. So the current distance is 0. Let's get our neighbor, which is B. And it has a weight of 3. So distance 3. And then our neighbor is B. We go check B. B is infinite. So we go here. Okay. B becomes 0 plus 3. So which is 3. Okay. And then B is pushed into the heap. Oh, okay. And then we pop. Right now we popped A. Okay, so pop A, which is 0. B's gets into our heap. 3, okay. And now we do the same thing for C. C. C, okay. And C has a weight of 5. And our current distance is 0 plus 5. And we know that 5 is less than infinite. So we add it to our array. Okay. And then 5 gets pushed into the heap. Okay. And then we're done here. We're done with A. And now in our min heap, which of our nodes has the shortest distance? That would be B. But first, let me update our graph. So A would be 0, B would be 3, and C would be 5. Okay. Now we go here. All right. And then we're here. So now we pop B out. So B's distance is 3. Okay. And then I'm just going to move this over here. Okay. B is pop. And B is 3. All right. So we check here. Current. So we go B. And the current distance is 3. So 3, 3. So we do not reloop. All right. And now we get the current. Go through here. We can skip. We know we could skip A. All right, we're just going to go C, D, and E. We're going to focus on those. C, D, and E. Okay. So here the neighbor is C and C. And then the weight, 1. Okay. So the current distance is 3 plus 1. So this equals 4. Okay. And then we check. This is 5. And we know 4 is less than 5. So this gets changed to 4 because we realize 4 is the shortest path. So we realize the shortest path is ABC, not AC. Okay. And we change this in the heap to C4. Okay. All right. Now we do D. All right. And we'll just change this here to 4. All right. Now we do D and E. Okay. And I'm going to keep it short. You know the pattern here. So D, it is 3 plus 8. 3 plus 8. The current distance plus weight, which is 11. And E is 3 plus 9, which is 12. Okay. Okay. And then I'm just going to put here. Okay. 11, 12. Okay. We're at C. And then just put them in the heap. Okay. Now we're going to pop C. Okay, so we're C and the current distance is 4. Okay. 4 and then the C 4, 4. Okay, no, does not apply. So we go here. And then for C, we're going to focus on, we're not going to go back. We're not going to go right because that goes back to the initial node where we start from. We're going to go left. I mean, we're not going to go left. That's where the initial node we start from. We're going to keep going right. Okay, we're going to keep going right. All right, we're going to keep going this way. All right. So we're going to pop C now. Okay. Okay. C is popped. Pop, and C is 4. Okay, so we're going to go right. So for the only node that's going in the right direction is, it's connected to C that's going right, is E. So we get E here. Neighbor is E, and the weight is 6. So okay, we go 6. Sorry, 6 here. 4 here. Which equals 10. And then right over here, we're going to go check E, which is 12. 10 is less than 12. So now E becomes 10. And it's on top, top of the stack. So we put E as the root here, 10. And then we change this here to 10. All right. Change the heap, okay. And then we're done at C. So now we're going to pop E. Okay. And this is 10. Okay. So this is now we pop E. Pop E. Okay. E is, pop it, E is 10. Okay. So we go here. All right. What nodes are going in the right direction? Connected to E that's going in the right direction? F and D. Okay. So let's get F. So we, okay, we'll just put here. Current distance is 10. No. All right. Then we go here. All right. So the current, we're gonna loop. So we're gonna get F, and it's infinite. All right. Sorry, it is 7. Sorry, 7. So 7 plus 10. So this equals 17. 17 less than infinite. 17 less than infinite? Yes, it is. So it goes here. 17, okay. You put it in the heap. All right. 17. All right. And then we change it over here. 17, okay. All right. And then for D, let's check D out. D, it's from F. We're here right now, so it is D. So we're at E here. We're here. Okay. It's 2. Okay. So we go, the current distance is 10 and the weight is 2. 10 plus 2, that's 12. 12 less than, what's the current one for D? 11. No, we do not change it. All right, and we're done at E. So now we move to D. We pop D out of the heap. Pop. Okay. And then D. 11. All right. And then we go. here, D, and we're just gonna get F. Okay, so we go here. Neighbor is F, weight is 4, so 11 plus 4, this is 15 here. 15 less than 17, yes. So I just want to make sure, okay, we just want to notify that we're here. So we change this to 15, okay. And this gets changed to 15. Okay. We're done. And now we go here to F. All right. And then we pop F from the heap. Okay. F. F it and the okay, 15. The current distance is 15. All right. From F, you can't see, we have nowhere to go, and we're done. And this is how we do a walkthrough through Dijkstra's algorithm. And over here in the distances, these are the min distances from A. So the min distance from A to B is 3. The min distance from, or the shortest path from A to C is 4. The shortest path from A to D is 11. The shortest path from A to E is 10. And the shortest path from A to F is 15. I want to thank you guys for watching, and I really appreciate you guys watching this video. And I hope you understand how this code works. All right. I'll be leaving this code on my GitHub, and signing off.